Hey, 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 welcome back everyone to another GoLab talk. We are just about to watch the video by Luca Cipriani called Building a Command Line Tool as the Core of Your Apps. I'll go ahead and bring him on really quickly while we read the bio and then we'll get started. So, hello, Luca. Oh, we can't hear you now. Your microphone is off.
Hello, Gophers. Have a nice GoLab, everyone.
Wonderful. Let me read about you a little bit and then we'll get started.
Sure.
So, about Luca here, having a big passion for Linux allowed him to become a system administrator at first and then an operations manager. After a few years of experience with some startups, he came back to Italy to help Arduino improve the development process. He is now the DevOps advocate and CIO of the company, changing the open source hardware movement. And about this talk, he is going to be talking about how they added gRPC on top of a robust and modular architecture to allow integration with GUI apps, a non-interactive interface for CI integration, and a library interface for developers. You can do it too. Arduino CLI has now more than 100,000 downloads thanks to this strategy. And based on 3 pillars, we will show you how Arduino created a command line tool to be used in many different apps and use cases. That was recognized as a successful pattern liked by the users. gRPC interface and external integrations will be the main focus of this talk. So before we go ahead and bring the video on, did you have anything you wanted to add?
No, I think you did already a great job in explaining everything. Thanks a lot.
All right, my pleasure. So everyone enjoy, and we'll have the live Q&A at the end. So if you have any questions to ask Luca, please go ahead and write them in the Q&A chat. It's the one with the question mark. It's not the help button. So ask your questions there, and we'll have him answer them live afterwards. Enjoy.
Hello, everyone, and thank you for being at the GoLab 2020. I'm Luca Cipriani, CIO at Arduino, and today I'm going to show you how we are building a command line tool as the core of our application and how you can do the same. So I wrote those slides thanks also to my colleague Roberto Sola. He's a senior engineer specialized in tooling. So how everything works and what we are going to see today. Here is a table of contents, so we are going to show what was the problem we were going to solve and how we started the whole idea of a command line tool for Arduino and not only, and how to let 2 different services or tools communicate each other. There are obviously many different ways to do that, and we explore what we have found being very effective for our use case. On the other side, we are going to see how we use the tools we developed as SDK in other projects. That's been very effective and also useful for ourselves also to design the rest of the part of the tool mentioned. And finally, how we integrated it with a real UI. So the separation between the front end and the back end of a command line tool is really interesting, and then some conclusion. So what we were going to solve was that we have a super popular graphical user interface IDE that's probably many of you already used. That's the Arduino IDE. It's a popular project. It's written in Java. It is almost 15 years old, and obviously the maintenance on that stack is very hard, so we had to renew it, and also there were some possibilities and exploration about having those IDEs online. So we wanted to refresh it a bit and also add some functionalities that are required by our users, so like auto-completion, debugging, being a bit more fast and portable, because that's also used in many schools, and also being more secure. So we wanted to modularize everything and allow other users also to integrate the set of the tools that they are the core of Arduino in their own solution. So that can be creating your own IDE or integrated it with Emacs, Beam, or many other popular IDEs like VS Code and others. So the idea is to separate a bit the core features with the presentation of the data. That's what we did. So I started design a command line tool, and that was the main goal was to let advanced developer first of all use the terminal, because we are also used to the terminal. They really love everything being in the terminal, as the popularity is gaining also for the GitHub command line. You can see exactly what is the standard workflow for a web developer, or more in general a developer. And the same applies for embedded developers that spend most of their time inside a terminal. And the other point was also to have some kind of tool that allow them to automatize many things, like including it in Bash script, or using some CI continuous integration of continuous deployment setup, also to automatically test new hardware. So obviously it's a lot of different use cases, but the idea was that this was a tool especially for experienced developers in mind. So I started designing with the help of Massimo Banzi the first draft of this document. As you can see, it's about 3 years old, so it was, so it was written in May 2017, and the idea, so where I started was to write a document and directly explaining the interface of it by writing a manual before it was actually implemented. So really was a kind of design exercise. So I wrote, as you can see initially, something like Arduino help was the first command that I designed, and I used Arduino -- version and -- help, and we envisioned using some standard command like init to create a template of the sketch or the project, compile to compile the command, doc to generate or fetch the documentation, upload to upload a sketch, and install to install many different things. Then we figured out that this wasn't enough, and indeed the last version completely changed the UI or UX, but that also came from a lot of feedback from our users, and also using the CLI by ourselves. And on the other side, we also had to respect a lot of legacy ideas and standard usage for experienced users. So you can't change the UX too much if your users are already used to use a specific tool. So this was some kind of RFC, and it had a lot of different updates. Obviously, the current version of this specific document was in 2019, and then everything became more or less public and completely open source on GitHub. And then is where part of the conversation started to happen directly in the open. So the requirements were also, the technical requirements were really sensible and hard to match all of them. So obviously this tool had to run on many different operating systems like Linux or Mac, Windows as well, but also with different flavors and support for different architectures. So especially ARM6 was something very important to us for something like Raspberry Pi Zero or stuff like that. And that also means obviously that Go was one of the right tools for the job, because we were avoiding many issues about having a portable binary. Then the other great thing about using Go, as we embraced already I think 5 years ago or so, was that the system APIs are extremely convenient and complete. So we are using some system developed by one of our colleagues in his spare time. That is a super useful library to manage serial ports, like this library, Go bug st serial, that really allows you to connect to a port, refresh the serial port and see if they show up again. So part of the code is also written directly in C and integrate very easily with Go. Then obviously having a single binary was a dramatic improvement for our users. So let's look at the different components. We basically have three different main components. One of them is the command line. So the command line itself has some support for different formats. So we figured out obviously that many systems or also scripts can use different ways to visualize and parse the data. So we do support usually either text, that is plain text, or format JSON. But even in some kind of test output, usually for some configuration that are aimed to be parsed by other systems, we basically use YAML. So on the left side you have this the JSON format that you can parse very easily with JQ or with your own, I don't know, JavaScript library or whatever you like. And on the right side you have the YAML output or the text output. And as you can see, the parameters are all the same, just different visualization. That's pretty handy and comes with a formatter in mind. So that's one of the components of the CLI, is indeed the formatter. Obviously to do this we leverage the ecosystem of Go libraries. There are those two super popular projects, Cobra and Viper. Some of us initially thought that they were a bit too big to include, but then we figured out we needed most of the features of them. So, and the other advantage is that community already knows it, so there is no need to re-implement something on our own when there is something that is super popular and working well. So yes, we support more or less everything that Viper supports, thanks to Viper itself, and the same for Cobra. So Viper really allows us to read and parse different config files, especially in JSON and YAML format, but we also are going to use M files. And then it's super handy to read environment variables from the OS. That's another big thing for us. And then there is a easy way to overwrite those variables at the command line. So that's pretty clear on how the chain of variables works with Viper. On the other side we have Cobra, and Cobra allows us to have some kind of sub-commands. So we have Arduino CLI init and something, or Arduino CLI core install, or libraries install, or library search. So we basically have subcommands that could be, as it was for a while in the Git command line, there were many different subcommands completely separated, and then there was a growing command altogether. We were trying to resemble the same, and then we decided to divide every subcommand in a kind of a module, and then we can wrap up everything by using Cobra. So how can we use the command line in our application? The whole idea is that in desktop application, usually as we were used until really a couple of years ago, maybe even less, everything is glued together, no? To achieve maximum performance, you have the front end and the back end basically not being separated and being the same. While nowadays we see a lot of systems that are kind of a hybrid, so they can work both locally and remotely. And then and in this case, especially because we speak directly with the hardware of the PC, obviously you need some way to directly communicate with the hardware, so it can't be something that's living only online, but you need some part on the user's machine. On the other side, we wanted to have something that could potentially also work online or remotely, especially in the IoT world. So let's imagine you can have some hardware connected to a remote Linux machine that you can compile and upload on that machine, and having a front-end UI for your code on your own desktop or online. That was another use case we thought we went to solve. So the whole idea was to divide completely the front end and the back end of a desktop application. That's a bit unusual, let's say. So how we did that? We did that by starting having a gRPC interface on top of the CLI itself. So every command doesn't only expose those text and JSON output, but the JSON output itself was a first attempt to go in that direction, while later on we figured out that gRPC was the perfect tool for this job. So we could allow many different systems and languages to speak this some kind of meta language. It is more like really an interface to interact with our command line tool, and that was pretty effective because gRPC is extremely easy to use and also extremely fast for our use case, and many different languages and tools already support it. So it's extremely useful for our community of users. The gRPC interface, just to give you an overview, so that's more or less what you what to write on the right, and then that's automatically automatically converting to a prototype and maintaining also all the comments. So the generated code by the gRPC toolchain is extremely readable, even if completely automatically generated, and that's pretty handy for us. So as you can see here, there is a board detail response, and we define some variable and do some configuration here. And this is the generated code. As you can see here, in the generated code, the comments are kept as they are. So name used to identify board to humans. In this case, if I go back, you see our name used to identify board humans is the name, number 2, and then it becomes this name string protobuf bytes 2 opt name proto3 JSON name omit empty. That's automatically generated, so it's a lot of boilerplate. We avoid thanks to gRPC. And this standard interface works with really a ton of different languages and dramatically helped us. And the fact that the comments are left here really gave us a huge advantage in terms of contribution with third-party developers, because everyone, even people that was not so good at understanding Go, which can be very hard for for developers coming from other languages, they were still able to read everything and understand what was going on. So that's really towards the ergonomy and the UX of the tool itself, and I have to admit the gRPC team is doing an incredible job in this regard. So how can I have my command line tool to be connected to other devices? So what we call in the IoT world like M2M communication. Obviously that's a bit stretch, but yeah, the idea is that you have this server in the command line. So we execute that with a daemon argument, and then you can see what's going on. So you have a config file that is sitting in a hidden directory. Then you have the CLI version, some metrics server on it, and then the TSP port that really allows the communication via gRPC interface. So there is this socket listening on the target machine, and in that case you can have any kind of gRPC client communicating with the CLI. Why is this useful? Because you can basically connect to it by using an interface, but we also went a bit further, and we were creating different modules for each of the commands that are reachable then from the command line. So this is the structure of the project. As you can see, there is this command directory, and then you have board, compile, core, daemon, debug, lib, sketch, and upload, and those are all commands of the interface, and each of them is also a Go module, so you can reuse them in other places. But let's have a look directly. Let's have a look directly to the. Give me a second. Let's have a look to the source code. So in the source code, here is the structure. As you can see, here we have the RPC interface, and in the commands, those are all the interfaces available for gRPC. So we can take a look at them. Those are the commands. So the commands, as we have seen, are those ones: update index, update libraries, update core, libraries index, and so forth. And then this is the generated code. As you can see, there is the init response, and that's the same for all the commands. So it's a very long file, obviously, but very effective. Then where are those commands? Those commands indeed are here, and in the commands we have board, compile, core, daemon, debug, sketch, and so forth. So let's look at something like upload. So for every module we also have the same module.go file, and then we start everything. As you can see, we use other pieces of the CLI as modules. Then we have the RPC interface as well, and the upload works like this. So we have the function, then we define everything that has to be done here, and we also call the commands directly from other part of the modules. So that's interesting, because then we can get some information and return everything on the gRPC interface as well. So that's pretty handy, and how the whole configuration works. So let's go back here. Basically, we are simplifying the interaction with the commands and try to create some layer of abstraction on top of each of the modules. But at the same time, you can also use directly the modules as they are, and that's pretty convenient. So we did that ourselves for some use cases. So because we started this design for the community, and then we figured out was extremely handy also for us. So what happened? We have this kind of boards, like this one. Yeah, this one has this Wi-Fi module on top of it, and the Wi-Fi module has its own firmware, which is completely different from the user's firmware. So in one chip, in this chip, there is the user firmware, what we call like the sketch is the source code of the user firmware, and then there is this other module taking care of the Wi-Fi communication, and they can be updated separately. So usually once the user writes its own code, it goes to the microcontroller, while updating the firmware itself of the Wi-Fi module is a bit more complex. So there is a firmware updater tool that allows you to do that, but the firmware updater itself, as you can see, is an external project on its own, and it's again written in Go, obviously. And in the firmware updater itself, we use the CLI modules to simplify many different things. Let's go a bit deeper about it. So here is how it works. So what you need to do is to first of all create something that goes directly in the microcontroller here, and that's your own sketch. So we write a sketch that is going to be written on the microcontroller. Then the sketch on the microcontroller configures an interface, a serial interface, a communication channel with the module itself. So they are allowed in this case to speak each other, because some of the pins of the Nina module are directly connected to the other microcontroller, obviously, for communicating. So we enable this communication in the first stage, and then in the second stage, the sketch executes a firmware upload on the other part, on the other chip, on the Nina module. And that's obviously it's not that easy, so it's multiple step thing, and we super simplified everything by using the CLI as a bunch of models. So how it works: to flash this specific chip, you need an external uploader. This uploader is an open source tool named Bossa, and it allows you to flash the microcontroller. So to flash the microcontroller, you usually call an external command. That's pretty easy. That's mainly because many different vendors use their own different uploader. So you can't have something that works with everything. You have to allow some kind of external execution of commands. So in this case we use a command to flash everything, and we call serialutils.reset. Serialutils is a module of our CLI that allows to send a reset to a specific serial port name. Then if it's going to be reset, then we start invoking BOSAC to upload the firmware, and then we wait for serial port or default to port, and in this case it means that every time you upload something, then the port is going to be closed and open again. So serialutils allows you to wait for the port to reappear and let the tool to reconnect to the same port. That's a bit tricky, especially if you have many different USB or serial devices connected to your own PC. And then finally, as you can see, you can also invoke BOSAC that uses another module. This module is executils that calls a new process. So basically here we were using executils and serialutils as modules. That was extremely handy. Let's see how everything works in this case. So serialutils.go is this module, and serialutils indeed declares this function reset that allows a port and either a true or false boolean to understand if someone has to wait for the serial data or not. The touch port usually for all the Arduino's bootloader is the same, so we explicitly define this function touch serial port at 1200 because that's a standard for Arduino, so it's not gonna change. Then we have the wait. If wait is true, then wait for new serial port of default 2. That's pretty handy and is used in the other system. While on the other side we also had the other function, which was executil, that I'm going to check. Executils is this module that allows the execution as a pipe basically of other commands, and then we fetch the output and put it in a buffer. This is pretty handy because we are able to execute external commands with a specific command line, and also pass some arguments that are usually parsed in some other way. And eventually we also have some other extra handy function like tell command not to spawn shell or stuff like that. So extremely easy, a few lines of code. Then obviously what is a bit more complex is having everything eventually on different operating system, and that has to be customized a bit for a specific OS. So in this case for Windows we have to add this hide window true for a sub-process to avoid having a quick flash of a new window in the UI. So that was the original idea. That's actually what's happening right now. So the upload tool uses the CLI modules in its own CLI tool and the binary itself. So that's pretty handy because it allows us to modularize many different things, and also the maintenance is a lot simpler for us because we can pin a specific version, but also at the same time respecting the same interface we are able to make updates to the CLI features, and if the major version doesn't change, then all the other tools are gonna gain some improvements in the CLI itself. And then obviously there was the third point. So the third point was to integrate everything in a UI. So we are gonna soon launch the new IDE, but the whole point of this was to have a nice UI that was something optional for those experienced developers, but at the same time is a great exercise also to show many other developers how they can create their own tools on top of this. The idea was this, to complete to have everything that's completely different. So we are using here web technology, mainly TypeScript and JavaScript, and well, I would say 99% is TypeScript. And so to have something that is still using web technology, so it could eventually run in a browser, and at the same time uses the gRPC interface either locally or remotely. And as you can see, the messages on the bottom right here, so those are messages directly coming for the CLI. Like, it's telling me that there is no core for this Arduino NKR Wi-Fi 1010. It's not installed. Use the board manager to install it. But the boards manager is exactly running Arduino CLI board install, core install. And then the same here. So it's telling me, do you want to install it now, yes or no? And if I type yes, then it will start the CLI as a subprocess and installs the core in the local machine. That's really separating the concern between front end and back end. As we are used to web development, is the same thing also for desktop environment. What was really more interesting is the communication with the serial port. So with the serial port you can easily send up to 10 megabits per second, but actually even a lot more on some OS, like 40, 50 megabits per second with our own devices. And in that case you will have to create a stream of data between the serial port and the UI, and to do that by using gRPC streams, that's extremely easy to be done, because we basically stream everything from the serial port to gRPC, and then there is an open socket in the front end that is listening to those data and immediately display them. So that's another big advantages. And here it is the same. So this is the output of the uploader, so the external command we have seen before. While we call an external command like bossack, this is the output. So this is the buffer we have seen in the external execution of a command. The main idea is to have some kind of one-on-one symmetry and feature richness between the front end and the CLI. What's happening right now is that the CLI is the first thing where we to update, where we release new features. So we first of all create a new feature in the CLI, and then we add it as a component at the UI level. On the other side is there are some features that are more UI related, like, I don't know, taking care of a login or synchronizing some sketches, that in that case we don't put all of them inside the CLI, but we prefer having this kind of logic specific to the application, so it can live somewhere else. So the idea is still to keep the CLI relatively small, so we don't need a really huge tool. It's already modular and can be modularized even more. So that's pretty much everything we've seen today. So the idea was to create a simple infrastructure for your API, but the infrastructure is all about creating a command line tool. This command line tool then can expose the data by using a standard contract. In our case is the gRPC interface, and with gRPC then you can plug a lot of external components to it and create your own command tool or even an entire UI, as we have seen, to leverage what we have right now. So we have seen people and even ourselves doing integration with GitHub Actions by using the CLI to integrate the CLI in a CI, in a continuous integration environment. On the same side, we have seen some popular projects like TinyML doing the same, so including the CLI for their own testing. That's all done by either using the text and JSON formatter, so the textual interface, and even putting it in a bash script very simply. Or for more complex use case, you can use this gRPC interface. And even further, if you want to really go beyond it, you could use the CLI as a bunch of Go modules specifically for your need. That's pretty much everything. So thank you everyone for being here at the GoLab 2020. Thanks also to my colleague Roberto Sora, and please, if you have any questions, do it here or contact me via email. The email is here. Thank you. Bye-bye.
All right, welcome back everyone. We are ready to go live with Luca to answer any and all questions that you guys may have for him. So let's go ahead and bring on live Luca. Hello.
Hello, hi everyone.
Yeah, welcome. First of all, thanks so much for your contribution to GoLab. We're really happy to have you here, even if this year it's virtually.
Thank you. It's always a pleasure. It's not the first time that I'm here, and this time is a bit different, but still extremely good. And I also seen there are about 40 participants, which is quite good.
Yeah, fantastic. I'm sure a lot of people have enjoyed your talk. And so before we go to any and all questions that people have, was there anything you wanted to add about either your talk or your participation in GoLab?
Yeah, I think probably if you really want to understand what we worked on, I really suggest everyone to take a look at the source code and also try the tools that we showed today, because really by figuring it out by yourself how everything works, you have a deep understanding on how to create a robust and scalable architecture for a CLI. So let's take a look at GitHub and search for Arduino CLI and look at the source code as well.
Yeah, get in there, get your hands dirty, play around with it. Learning by doing is the best way for pretty much everything. Yeah. It looks like nobody is putting in questions. Are you sure, guys? The many of you who are watching, you don't have any questions for our dear Luca today? We have a thank you from Andrea Favilli from Develer. So yes, we are happy to have you here.
Yeah, I'm sure some of you will have some question, maybe about the internal details or even on how we use it with external tools. So just let me know and don't be shy.
Yeah, you guys, don't be shy. We always have a few questions, even small ones. There are never any bad questions here. They're all so quiet. Well, hopefully that means that you made a very clear talk. Yeah. And yeah, since we have a little bit of overtime and nobody is asking their questions yet, you can definitely add something.
Yeah, what I would like to add is that in our project, especially in the graphical user interface we use to create the new Arduino IDE, we are using web technologies to speak with this command line tool. And this is pretty interesting because basically you are bringing web tools to desktop environment. And at the same time, we are also using TypeScript as a language that really shows the great interaction and interoperability of the gRPC interface. So even by using different languages, and TypeScript is really, front-end oriented in many different ways, and is a superset, let's say, of JavaScript, it still talks extremely well with the gRPC interface written in Go. So that's, I think, more in general, a good feature of the Go ecosystem. So the libraries, as I mentioned, are so powerful that it's extremely easy also to integrate different languages. The same it was with the internals for the serial API, where we used many parts of the code written in C. That's a completely different language again, but still very easy to integrate. So speaking with, let's say, lower level languages was done directly by using the internals of the language, and while speaking with the interpreted languages is done by the gRPC interface. I think that's really a great lesson we also learned ourselves on how to scale and design tools.
All right, thank you for that. And we do have one question. Yay! So we have one question that was, what was your experience using Viper/Cobra with modules? The generation was a bit tricky with modules when I last tried it.
That's true. So for a while, also the Viper and Cobra projects seemed a bit hiding a bit and not being completely maintained. But then lately, they changed part of the maintainers, and as of now, it is currently continuously maintained and very often with great updates. So yes, I have to admit it was a bit tricky initially, but then after we figured out the fact that we had also tests for pretty much everything allowed us to refactor a lot of code in a relatively short time. So I would say it could be improved by some extension, but on the other side, it was a lot simpler than many people said about Go modules. So I heard many developers saying the Go modules things is going to overcomplicate everything, but I can say that from our experience, it wasn't so dramatic. It was also a tool for us to, an opportunity to refactor many different things.
Great. Oh, and we have lots of questions coming in too. So let's go with the next one here by Ilan, who says, if you have many Arduinos running as IoT, how can you get the CLIs to update themselves to a new version in some kind of pull way when they find a signal to the network?
Okay, so yes, you can do that. Now, honestly, what we are working on, and is going to be announced before the end of the year, is the fact that there is going to be a way to update your device via over-the-air updates, and that's obviously completely different. But as of now, with the CLI, if those devices are directly attached via USB, you can immediately trigger an update. Otherwise, the update to a local network in the CLI is not yet available. But on the other side, the CLI allows to plug third-party plugins also for the uploader. So what we are working on is on having a way to also support over-the-air updates in a local network. While for more generic Arduinos, in that case, we are going to support the over-the-air updates directly by using our Arduino IoT Cloud service.
All right. And a similar question here about gRPC. Do you run the server on the Arduinos or on the developer's computer or both?
The gRPC server runs directly on localhost on the developer's computer, but the nice fact about it is that it can also run on a remote, let's say Raspberry Pi or a remote server where some of the Arduino boards are then connected. So the architecture is really flexible. As of now, it can't run on the smallest Arduino because the smallest Arduino really have something like 64 kilobytes of RAM, which is really too tiny to even run a gRPC server.
Sure, that makes sense. Yeah, it's too tiny. Let's see. Any other questions? Okay, he just says thanks. I think that was our last question. Are you sure, guys? Any others while we have him here? All right. Well, if that was the last question, then I would like to just take this moment to say, hopefully next year we'll have you here at GoLab as well. Definitely an honor. Definitely a pleasure to have you. And hopefully it will be not virtual. Let's cross our fingers that way. But even if it is, hope that you can come again anyways.
Let's hope so. And thanks everyone for staying with me.
Yeah, definitely. All right. Well, I hope you enjoy the rest of GoLab, Luca, and we'll see you around.
You too. Thanks a lot. Bye-bye.
Thank you so much. Bye. All right, you guys. So we have one more talk for the rest of the day. Before I announce that one, just a reminder, you can rate this on the agenda page of the site if you liked this talk. It's really good feedback for all of our speakers to have that. So the last talk of the day, which starts in about 20 minutes, is Running Go on the Smallest Systems with TinyGo by Ike van Latham. So hopefully we'll see you there. Bye-bye.